So in today's video, I want to talk about how to build production AI phone agents or phone callers, however we want to call them. I feel like in all of my videos, I kind of talk about this narrative of, the difference between demo and production. And I haven't yet made a kind of full video on how to build production AI phone agents or AI voice agents or whatever we want to call them. And I think the reason why I haven't done that is because the topic feels extremely loose and quite a holistic thing. And I don't think there's a single thing that you kind of tick off and like now you're in a production AI voice agent. I think for me, the gap between demo and production systems, just like it says here, is the amount of problems you solved. If your system solves, hundreds of problems, small, tiny little differences, that is kind of where, in my opinion, you start to get to that production status. And obviously, just like accuracy, reliability, all those kind of things is also, to me, what signifies production. But in this video, what I want to show you is kind of, how would I best describe this? Like, I want to open your eyes to how production looks in terms of solving the problems that production faces and these types of things, just to give you kind of, uh, a kind of concept of what that even looks like. So an example of a demo system, I think anyone who knows what an AI voice agent is will know what this looks like. We've got the speech to text, we've got the end of utterance kind of component, which can either be a turn-taking model, it can be VAD, it can be whatever we want. Then we have an LLM, and obviously, we're going to have some tools, we're going to have some RAG, something like this. And then we're going to have text to speech, which is obviously connected to some sort of telephony provider, like let's say Twilio. So that would be our kind of demo system. It works, like especially if we're using a fast LLM, it's going to sound decent. Obviously, the text to speech and the speech to text is kind of a plug and play component. So, the difference between a demo system when it comes to the text to speech and speech to text is going to be the same as a production system because, unless you're doing it on-prem, that is going to be the same. But the difference is essentially in the LLM and also what are we doing after the call or before the call, these types of things. So an example production system for the LLM section would be, or for like the whole pipeline section would be, again, speech to text, end of utterance. That again doesn't really change. But then we might have we will have a lot more kind of happening within the LLM. So we first might have an injection guardrail to make sure that, what the user is saying isn't trying to kind of get information out of the AI that shouldn't be given. So we have that at the same, in parallel. So when it's kind of like, three things on top of each other or two things on top of each other, I'm kind of trying to signify in parallel. So obviously we can reduce latency. At the same time, we will do intent classification. So if the user says, I want to book this thing, we will kind of, classify that intent as booking, or if they want to cancel, we classify that intent as canceling. We'll also query the company knowledge, so their RAG. So, are they asking about, are we open for Thanksgiving or are we open for Christmas? These types of things. So we will have our company knowledge and RAG. Then we might have like an examples RAG, for example. So what I mean by this is, let's say we're in a conversation and the conversation is about booking an appointment for a med spa, and the customer wants to do this specific appointment, etc., etc. We might want to have a specific example that is inputted into the system prompt based on the kind of user conversation. I think, in my opinion, from my kind of prompt engineering experience, examples are just by far the best way to improve an LLM's outputs, because you can literally give it a golden output. Here is exactly what I want you to look like when it comes to when you use your tools, how you respond, these types of things. And so to me, examples are huge. And so if we can kind of have a RAG that injects examples at the right time in the conversation, that would be really, really valuable. And, something that could be a good problem to solve in a production system. We might also have more than just this, like company knowledge examples. So here we could also have, my scenarios RAG. In my opinion, scenarios RAG is huge. Like, for example, if the user says this, then do this. I think that is huge. I mean, so easy. You can so easily kind of create this loop where if the user says something, the agent can respond. We kind of flag that and then we can improve that. Obviously, that is a very, very important thing to do. So let's say we just do these three for now, and then we render the prompt based on the intent classification, the company knowledge that was retrieved, and the examples. And then we obviously add the tools that the LLM needs. Once we have kind of all that context, we would then actually call the LLM and get it to respond. So let's say we're working in a med spa, we obviously need PII, which is basically to do with not like listing the or saying the information of the person. Then we might also do a hallucination guardrail at the same time, just to make sure, based on the instructions, based on everything like that, did the LLM actually do something correctly? And then if it passes both those things, we would respond and send the response to the text-to-speech, which is then obviously going to output just like the demo system, and it might be connected to a better, slightly a telephony provider like Telenix. The reason why Telenix is slightly better is because they're private, they have their own infrastructure, whereas Twilio is kind of like a middleman to normal phone networks, and so Telenix has a bit of a better latency because they have their own private infrastructure. So that's kind of like the the LLM side of things. I mean, within here, this is even quite a small production LLM pipeline. Like you might have, like I said, the scenarios rag. You might have another thing that kind of checks just specifically, I don't know, what offers is the med spa running right now? Because obviously, med spas will have a $25 off for spring, if you use code spring 25. These types of things. And so we might need, an extra kind of database query that basically gets those offers. And we might need to do another thing here and there. And obviously all those things are problem solved, where like if we didn't have that in our LLM side of things, that would be a problem, that the LLM and the AI voice agent wouldn't be able to answer what offers that the person or what offers does the med spa have. So, there's going to be a lot more here to do with obviously what kind of niche you're working on, which obviously, again, I made a video about GHL, and you really should be niching down unless you're doing like really big bespoke solutions, at least in the future. I'm going to make a video probably on how to build and sell AI voice agents, where I'll talk a bit more about like the business model of AI voice agents or AI phone agents. So yeah, if you find that interesting, that should be out soon. Now let's look at like the difference between like well, I guess demo wouldn't even do anything after the call, but like what would a production system look like after the call? So let's say the call ends. The first thing we would do is we would analyze the intent classification. So, it's really important that the intent classification gets it right. So if the user says, I want to book an appointment, and we accidentally classify that as canceling an appointment, what then? Like that's obviously going to screw it, because the prompt is just going to be incorrect for what the user wants. And so when we call the LLM, the hallucination guardrail will find it fine, because the prompt, it did what the prompt did, or it did what the prompt said. The PII guardrail hopefully would be fine. And so it'd respond to the text to speech, but the intent classification was wrong. And therefore, the response is going to be incorrect. So we obviously want like a smarter LLM, like a GPT-5, like a Kimi K2, like a thinking like a Anthropic, or Gemini, whatever. We want to analyze the intent classification and basically check like, was the intent classifier correct? 95% of the time, whatever. And if it isn't correct, what we do, which is kind of like the again, like a big goal of production, is like having a feedback loop where these things, all these components like the LLM, the intent classifier, the injection guardrail, the hallucination guardrail, the PII guardrail, the main LLM, all of these things can improve. And the way that happens is by like a better LLM deciding, look, it probably messed up here, and then we take that part that it messed up in, and we basically add that into like a data set where we kind of have what the golden output was. Does that make sense? So if the LLM, classified, I want to book an appointment as cancel_appointment, obviously that's very unlikely. Like the intent classification will probably get that right, but let's just say in this example, it did do that. We get the smarter LLM, which very likely won't mess up, to be like, okay, look, you messed up here, and this is what you should have done. And then we add that data set into like this kind of data set, which we train the intent classifier on. And then we can retrain the intent classifier in order to be able to kind of improve it and get it to not make mistakes in that kind of scenario for the next time. So that's what we kind of do in production. So we have that kind of feedback loop. We would have this exact same feedback loop with the hallucinations. we'd get like a smarter LLM to analyze the hallucinations, find out what was the hallucination and why the thing that the main LLM here did was a hallucination. Try to fix that again. We would have an LLM analyze the conformity to instructions. Was the LLM, like again, this main LLM listening to the instructions? Was it doing what it was told to do based on the prompt that was rendered and the tools? We also might have a multimodal LLM, like a Gemini 2.5 Flash, or any sort of LLM that kind of understands audio, not an LLM that just transcribes the audio and then, says things based on the transcription, but a literal LLM like Gemini 2.5 Flash that understands the audio based on the actual audio and encodes encodes the audio as a token rather than transcribes it. And what we could do with that multimodal LLM is just to check for text-to-speech errors. So it would notice when sometimes the text-to-speech says something weird where it's like, and it just says something incorrect because there was just an incorrect generation with the text-to-speech. And, we might flag when an error happens so that we know at least the data of how many errors are happening, especially when it comes to text-to-speech. So we might do that in our pipeline too. Any errors that are kind of like, I don't know, conformity to instructions, or like maybe we also have, again, I didn't think of this whilst planning this video, but we might have an LLM that analyzes, was there an error in the sense that, was there a thing that the LLM wasn't able to do? So was it not able to answer this question? Was it not able to do the thing that this person wanted? I.e., let's say they wanted to change the person that they're doing a massage with, let's say. And our kind of voice AI system didn't have that as an option. And so hopefully our kind of main LLM would have just said, look, I can't do that for you. Like, I don't have the ability. And like in our post-call analysis, we have an LLM that's like, oh shit, like, look, we are not able to do this in our voice AI system. Let's escalate that to a human. And then a human could actually write the instructions and obviously improve that system. And then that would be kind of pushed to allow our voice AI system to kind of be constantly improving. So let's say, yeah, if the error was to do with company knowledge, like, I don't know, we didn't have that answer in the company knowledge, like in the knowledge base, we flag that to a human, the human adds the answer, and then that's added and updated into the company knowledge base. So the next call, when that exact same query is sent to this stage of the pipeline, the answer will be within the company knowledge base, and then hopefully, the LLM would respond with the correct thing. And if it doesn't respond with the correct thing, we would notice that, I don't know, in the conformity to instructions, and we could fix it somehow where we could analyze the instructions, be like, are there some sort of competing instructions where two instructions are telling it to do two different things? And so we could figure out that way. But ideally, it would respond correctly, which it likely would if the system is built correctly. If the error is to do with bad intent classification, like I said, well, yeah, human can create the gold output. So either the human can say like, this is what I wanted it to do. That is probably better. But if your system is huge, a human will be doing a lot of intent classification gold output, which, might not scale. So you might just give that to a smart LLM like GPT-5 Pro or whatever, even if it's worth it. But otherwise, you can have a human create the gold output for the input, which is basically what did the intent classifier get and what should it have outputted instead of the incorrect thing. And then we can re-optimize that intent classification prompt based on the data set, basically. And in case you don't know what I'm talking about, optimizing prompt, there's something called DSPY, which I will probably make a video on. In fact, I might make that my next video because I think it would really be valuable. But like, there's a thing called DSPY, and they have something called JEPA, which is GEPA, which is a prompt optimizer, which is insane. Like, it's really technical. But basically, you give it a data set, and what happens is we run through that data set, constantly tweaking the prompt. The prompt is tweaked by another LLM, and we basically keep running on that data set with different tweaks to the prompt until it has improved the overall score of the LLM, like the intent classifier, to the data set. And then if it has improved the score, we like kind of save that prompt, and we just keep doing that until it improves. And it really does help the prompt to actually be like, more accurate, more consistent, more everything like that. If the error is a text-to-speech error, we might just like check the LLM input, because obviously sometimes if the LLM inputs something like a 5 and a dash and then 10, the text to speech quite often will go 5-10. Like it will just mess up, but because that kind of input is not what the text to speech would prefer. It would prefer like a 5. Well, so let's say, for example, we're saying 5 to 10. Like we have space from 5 to 10 p.m. Obviously, that's whatever. But anyway, let's say we're doing that, and the LLM inputted or outputted, sorry, 5-10. Then the text to speech would say 5-10, quite literally, which we would kind of classify as a text to speech error. So we would, if it's like the bad input, we would fix the prompt to make it go 5-TO, like literally 5 to 10. And if it's not to do with the input, then we can obviously test another text to speech model and basically like kind of flag that error. And just to make sure, like, we're using the best text to speech model. And regardless, that kind of data is useful. Okay, so that would be kind of our like instantly after the call analysis. So like just basically making sure it did what it should have done. If there are any bad things, we escalate to a human to basically allow this system to loop and improve constantly. And then next we kind of have like this second part, which is like the more holistic analysis, I guess you could call it, which is kind of analyzing not just like the one call, but all of the calls. So once we've stored all the data, like per call, we might analyze thousands of calls and try to find like, what is the common issue? Is it like the biggest issue right now that the LLM's hallucinating, or is it actually that it's not conforming to the instructions? Or is it that actually, the LLM could do it, but the classifier is kind of messing up often, and therefore we need to kind of put more focus on improving the classifier? Or is the text to speech error happening a lot and we need to just change the text to speech? So that's like a third part, which is, kind of holistically improving the system based on thousands of calls, rather than just like improving the system based on the issues of a single call. But we obviously need both those parts. So I think like a bit of a checklist in terms of like what to me is enough to kind of be labeled as production. I know I said like at the start of the video, production isn't like this checklist. I mean, uh, even though I'm quite literally saying that this is what the production system checklist is, it isn't though. At the same time, it's just kind of like, this is kind of like the things that you have to be doing, because otherwise you're absolutely a demo. But obviously, yeah, I would say there's no kind of point where like now you're production, in my opinion. As long as it's working well, I would label it as production, but I think it needs to be doing some of these things, in my opinion. So the first thing, I think it needs to be collecting data. So the latency, where is the origin of issues? Like I just said now, is it to do with the intent classification? Is it to do with hallucinations? Is it to do with the conformity to instructions? Is it to do with the text to speech? Is it to do with the speech to text? Is it to do with interrupting them? Is it to do with this, that, etc.? Is it to do with background noise? All of this data needs to be stored, because that is so useful for you to understand how can I fix this system. And that is the whole point of a production voice AI system. It needs to be living, breathing, and constantly improving. If I go onto something like FinAI, let me just pull up. Why is my browser not working? If I go onto something like FinAI, which in my opinion is like the most widespread AI agent in the world. Like I wouldn't say ChatGPT is an AI agent, and also nobody is using like nobody's using their agent mode anyway. So I would say this is kind of the biggest AI agent, the most widely used AI agent, and probably the most production AI agent out there. So we kind of want to think of our AI agents in this scope. And so look at their system, for example. This is how it's improved over time. May 2023, it handled 23% of the tickets it got. Now, in October 2025, it's November now, so they'll release a new one soon. It's handling 66%. As you can see, there's no one big jump where like you would expect, oh, GPT-5 was released and like that caused it to go. I guess this was the biggest one here, like a 4% one. And that was probably some model, but for some reason they went down and back up. So it's kind of like average to like 1% per month, except for like right at the start, which is fair enough, because that's kind of like as they got really quick and a lot better. And so we want to think of our system in that way too, where, we're just going to get better 1% every month. And to do that, we need to have data to allow us to know where is the issues and what is causing us to not, handle every single call. So the next thing would also be like, yeah, golden examples slash outputs. So more golden examples for intent classification, more golden examples for the LLM analyzing and conforming to the instructions. So like if the voice agent, the AI phone caller did a perfect call where it answered everything perfectly, can we, extract that golden data set and actually train the LLM to make it know like this is perfect, like this is what we want, and get it to be more commonly good. So that's, for example, something else. The second thing I would say is it needs to have a feedback loop that allows it to improve with time. Obviously, this is what I kind of just said. That's to do with collecting data, and humans should be able to improve it. So, in my opinion, like just having LLMs improve your system is a little bit like risky, and so I think like having a human manage the system in a way and basically say like, look, this was a company knowledge base error, here's the answer, this is a kind of lack of system tool error, whatever, this is how we improve it. It needs to have some sort of feedback in the loop, and the only way you can really do that, in my opinion, in production is by having these kind of like knowledge base things that get improved rather than like literally changing the prompt. I would much rather change the prompt. I'd much less, sorry, rather change the prompt than like add things into RAG, and then that RAG is then added into the prompt. Does that make sense? Like I want to leave the prompt as simple and kind of as static as possible. Number three, it needs to be testable. So can we reproduce the calls? I think this is really important. Can we reproduce the calls? Literally, if it's a bad call, can we like take the audio of that call and reproduce it and try to like, based on, let's say we've improved the system after analyzing the bad call, we've done the fixes, and then we reproduce that call. And if it gets it correct, amazing. Like we need to know that after a bad call, we fix it, we reproduce, does it fix? Yes, no. If no, we try to fix it again. If no again, we try to fix it again until we get a yes, and then it's actually fixed. And so that allows us to basically know after every call, we have improved the system, which is what we want. We want like a 0.0001% increase of the overall system's capability, after every call, especially a call that is failed. Number four, it needs to be secure. I guess that's kind of a bit of a more boring one where it's not to do with as much like stuff. It's just more like you need to make sure it's secure. You need to make sure your APIs are behind API keys. You need to make sure that the data that you're sending to providers isn't illegal. Make sure it's compliant. Those types of things. Those last two things are kind of just more the boring production system checklist. So I think hopefully that was quite useful. I know it's a bit of a rambly video where it's not like very structured, but I think it's just useful to talk a little bit more authentically, talk about like what the difference is between production. I think like, yeah, I can't tell you like if you have injection guardrails, like now you're production. That's not really how it works. Like to me, the core essence of production is, yeah, how the gap between demo and production systems is the amount of problems you've solved. The more problems you solve, however you solve these problems, whether it be with a tiny bit of code or whether it be with some complicated LLM agentic system, however you solve these problems, if you solve them, that is the difference between a demo and production system. And you never really reach a peak because there's always a little percentage more to extract, and you can always do a little bit better. I mean, like I said, FinAI, what they've been running for 2 years, and yet they still don't resolve 100% of the cases, which makes a lot of sense. But yeah, they've got years of improvements still to go. And, it might take them another 5 years to get to 90%. And then it might take them another 10 years to get to 95%. And then it might take them another 10 years to get to 99. And like, there's always going to be more for the production systems to do and the more problems to solve to make them even further away from demo systems. So yeah, thank you for watching, and hopefully you found this video valuable. If you have any questions about voice AI in general, you can join my community. I'm trying to keep it a little bit more active there. I answer some questions here and there. I also respond to YouTube comments all the time. So send a question down there if you have any thoughts about this. Thank you for watching, and I'll see you in the next video, which will probably be about prompt optimization, and then potentially how to build and sell AI voice agents, kind of the business model, as well as obviously like how I build AI voice agents to kind of get them up and running fast and well. Thank you.